Have you ever wondered how the universe began? Do you know there are two theories about how the universe began? One is well accepted by almost everyone in the scientific community, and another one is gaining traction with some scientists who have serious concerns about the current best model. In this episode of Show Space, we'll explore both of these ideas and ask whether the evidence really does point towards one of them being right. The Big Bang Theory describes our universe's evolution from an extremely hot, dense state billions of years ago to the universe as we know it today. It's backed up by lots of evidence, like the redshift of distant galaxies, the cosmic microwave background, radiation, and the abundance of light elements like hydrogen and helium. But when you look at this theory and try to use it to understand what happened before the Big Bang, things break down pretty quickly. Like, if the universe started with the Big Bang, then what was it that caused the Big Bang? And if the universe had a beginning, does that mean it could also have an ending? These questions, and others like them, show why the Big Bang Theory is the only idea out there for how the universe began. Competing idea is called the Big Bounce Theory, which suggests that our universe is just one of many that have come into existence over an infinite amount of time. The Big Bounce Theory is sometimes referred to as the oscillating or eternal or infinitely cycling model. But bouncing back and forth between bangs doesn't describe how gravity works, so people tend to favor the other names. The main difference between the Big Bang and the Big Bounce is that while the former says the universe began with a bang and has been expanding ever since, the latter posits that the universe has been expanding and contracting indefinitely. Okay. So, under the Big Bounce Theory, what we refer to as the Big Bang was actually just one instance of the universe expanding after a period of contraction. Proponents of the Big Bounce Theory think that their model addresses some of the issues with the Big Bang Theory, such as the horizon problem, which has to do with how large patches of the universe appear to be in causal contact with each other, despite being so far apart that light has had time to travel between them. In short, the Big Bounce Theory offers an alternative explanation for how the universe got to be the way we observe it today. So, what does the evidence say? First, let's look at the evidence that supports the Big Bang Theory. The first piece of evidence is the redshift of distant galaxies. The farther away a galaxy is from us, the faster it appears to be moving away. This observation fits nicely with the Big Bang model, because if everything is moving away from everything else, then it makes sense that all the galaxies would be receding from us. If they were all moving toward us, that would be weird. Next, there's the cosmic microwave background, or CMB for short. This is basically a snapshot of the universe when it was about 400,000 years old. The fact that we can see this radiation and that it's incredibly uniform across the sky are both explained by the Big Bang Theory. Other observations that support this theory include the abundance of light elements like hydrogen and helium, as well as the large-scale structure of the universe. All of this evidence fits together and creates a fairly compelling case for the Big Bang Theory. However, it's not perfect. For example, it doesn't explain what caused the Big Bang in the first place. There are also some issues with dark energy, which is a hypothetical form of energy that is thought to make up about 3/4 of the universe. Scientists don't know what dark energy is or where it comes from. Its presence creates another issue. You see, according to Einstein's equations, the universe should be slowing down as it expands. But observations indicate that the expansion is actually speeding up. And this speeding up can't happen unless there is some kind of repulsive force pushing against the gravitational attraction of all the matter in the universe. That force is dark energy. So while the Big Bang Theory explains a lot, it leaves a lot of questions unanswered. And that's where the Big Bounce Theory comes in. Proponents of the Big Bounce Theory claim that theirs is a more complete model because it doesn't require dark energy. Instead, they argue that as the universe begins to contract, the roles of matter and antimatter would flip, and what we see as matter would become antimatter, and vice versa. This would cause the expansion to flip, and the universe would begin to bounce back. But does the evidence support this idea? Well, there are some observations that seem to fit nicely with the Big Bounce theory. For example, there's the issue with the horizon problem we mentioned earlier. The Big Bounce theory solves this problem by allowing the different parts of the universe to be in contact with each other before they were so far apart that light could untravel between them. There's also the flatness problem, which has to do with the fact that the geometry of the universe appears to be flat. Okay? In other words, parallel lines never seem to converge. According to the Big Bang theory, there's no reason why the geometry of the universe should be flat, but it just happens to be that way. The Big Bounce theory, on the other hand, doesn't have this issue because it assumes that the universe was flat before it began contracting. Finally, there's the issue of dark energy. As we said earlier, the Big Bang theory requires the existence of dark energy, but the Big Bounce theory does not. Instead, it relies on the equivalence principle, which says that gravity should be the same everywhere in the universe. However, these observations aren't enough to say for sure that the Big Bounce theory is correct. For one thing, the equivalence principle has been challenged by some physicists who argued that gravity does behave the same way in all parts of the universe. That's not all. There's also the problem of the magnetic fields. The Big Bounce theory has trouble explaining how magnetic fields get so tangled up in the universe. And there's the issue of black hole information loss, which is a problem for any theory that tries to explain how the universe began. This is because black holes have a tendency to destroy information. They do this by crushing anything that gets too close to them and then emitting radiation that eventually dissipates into the surrounding medium. This process destroys information about whatever was inside the black hole, and it poses a problem for the Big Bounce theory because it means that the universe would have less information in it than it did before it bounced. For these reasons, the Big Bounce theory hasn't gained much traction among astronomers and cosmologists. Most of them still favor the Big Bang theory, even though it doesn't explain some of the observations we mentioned earlier. Some researchers also worry that the Big Bang and Big Bounce theories are indistinguishable from one another. That's true, then it means that we can't rule out either theory based on the evidence we currently have, which leaves us with more questions than answers. Still, the Big Bounce theory is an interesting idea that may gain more support as scientists learn more about the universe. So what does the future hold for the Big Bang and Big Bounce theories? Well, one possibility is that the Big Bang theory will be modified to account for some of the observations that it does and currently explain, such as the horizon problem, the flatness problem, and the speeding up of the universe's expansion. Another possibility is that the Big Bounce theory will be refined to address some of its shortcomings, such as the issue with magnetic fields and black hole information loss. Yet another possibility is that neither theory will be able to explain all of the evidence, and that we'll need to come up with a completely new model for how the universe began. Whatever happens, it's clear that the debate between the Big Bang and Big Bounce theories is far from over. So what do you think? Do you think the Big Bang theory will be modified, or will the Big Bounce theory prevail? Let us know in the comments below. And be sure to subscribe so you don't miss any of our future episodes. Thanks for watching.